Okay, let's get started. Hi, I am the Korean PLC helper. Today, starting part 2 of the device explanation. First, we will discuss timers. A timer commences measurement when the coil is activated and the contact. Okay, this is T0 contact. Give me a second. This is T0 contact. And this is T1 coil. T1 contacts, M0 coil. Okay, this is coil, this is contact. However, a timer commences measurement when the coil is activated and the coil is activated on, and the contact is activated when it reaches the preset value. Preset value, example for K10. The timer employs an additive structure. Timers are broadly classified into two main types. The first type is a timer that resets its current value to 0 when the coil is deactivated. It's timer. And second type is a retentive timer. Retentive timer that maintains its current value even when the coil is deactivated. Each type can be further subdivided into high-speed or low-speed timers. Whether a timer is designated as high-speed or low-speed is determined by the presence of the H command. T1, it is a timer, low-speed timer. High-speed timer is HT1. And the measurement units for high-speed or low-speed timers can be configured in PLC parameters, PLC system, and timer limit setting. Okay, I will show you. Okay, PLC parameters and system timer limit setting is here. This is here. It is crucial to ensure that the timer's measurement period setting value is not shorter than scan time. If it is shorter, proper operation cannot be guaranteed. First, we will examine the low-speed timer. Low-speed timer has a measurement unit ranging from 1 to 1000 milliseconds. When the coil is activated, the timer initiates measurement, and the contact is activated when the set time elapses. Coil 1 second. This is 1 second, and X1 is on, T0 coil is on. 1 second after, T0 contact is on. When the coil is deactivated and X0 off, the current value reset to 0 and the contact is deactivated. Next, we will explain the high-speed timer. High-speed timer. Other CPU types utilize measurement units ranging from 0.1 to 100 milliseconds, while universal CPUs use unit from 0.01 to 100 milliseconds. The method of use is identical to that of the low speed timer. X01, X01, and T200 coils on, and 0.5 seconds after T200 contacts on. This is H commanded. And next is retentive timer. When the coil is activated, the timer starts measuring and the contact is activated when the preset time is reached. Even when the coil is deactivated, the current value and the contact status are retained. Like this and like this. When the coil is reactivated, the timer resumes measurement from the current values. Okay, ST0, K200, ST1 coil runs measuring preset value 50 seconds and reactivated 5 seconds. The current value and contact can be reset using the RST STN commanded. The high-speed retentive timer functions identically to the regular retentive timer but differs in its measurement units. Now we will create a timer and retentive timer to examine their differences. Okay, first scan programmed editor. Chicken, no. First create an M0 contact and 30 second timer 0. T0 and K13 300. The reason 30 seconds is entered as K300 is because the time interval was set to 100 milliseconds. An input value of 300 corresponds to 30 seconds. Below that, create an M1 contact and 30 second retentive timer ST10. And M2 contact is RST ST10. Okay, let's get to simulate it. Let's go. When this M0 is activated, the timer coil becomes active and the current value begins to increment. When M0 is deactivated, the current value reset to 0. Did you see that? When is M0 reactivated, the T0 coil turns on, and after 30 seconds, the T0 contact is activated. Please give me a 20 seconds. 8, 9, 10, 13. T0 contact is on, and M0 is deactivated. The current value reset to 0 and T0 contact is deactivated. Next, we will look at the retentive timer ST10. When it's M1 is activated, the timer coil becomes active and the current value begins to increment. When M1 is deactivated, the current value is retained, like this. M1 is reactivated and okay, give me a 20 seconds. I mean, when M1 is reactivated and the ST10 contact turns on. Oh, okay, I created ST10 contacts, coil M101. Okay. After 30 seconds, ST10 contact is on and coil 101 is activated. Even if M1 is deactivated, the contact and current value of ST10 remain unchanged. Current value is 300 and ST10 contact is activated. Executing the RST ST10 command will reset all value and signals. Okay. Precautions when using timer. The same timer cannot be used multiple times as RT용 within a single scan, similar to using double coil. Okay, like this. T0, T0. And simulators off. Check program. Duplicated. Yeah. Across error. And if the timer is not executed in every scan cycle, the current value will not be updated. For these reasons, timers cannot be utilized with interrupts. Okay, that's all for today. Thank you for your hard work.